It is time to build our first machine learning model of the Machine Learning Model Master class. Very exciting. I also want to apologize for not doing this on lesson one, because it's the main event. We're going to do a lot of it, building machine learning models and analyzing them. But you've got to do the data cleaning, and I already talked about why. Okay, so how do we do this? Well, the first thing we do is we get the model that we want to use. Let's just start with linear regression. Okay, we'll compare it to XGBoost at the right time. And so you have to find where it lives. Okay, from memory, it's from sklearn dot. If I think it's a linear model, I can start to type that in, and you can see it as linear model. And we're going to import linear regression. This is the thing, you don't have to guess, you can start to type. Now it's not prompting it for me, so it doesn't always get it, but there it is, linear regression. So then you know it's right, that's my point. Great, so it's been imported, and you can always press Shift and Enter to run it. I'm just going to go ahead and put in the chunk of code to actually build it. So I initialize a model, and certainly I'm going to initialize what I imported. It's default linear regression. Now I'm going to fit it to the data, okay? And I say that, but I can't actually do it yet. And the reason why is because I haven't split the data. This is actually something that happens to me. I get overexcited and I want to build the model, but you actually got to split the data first. So, I should make that, maybe it's on subheader. Let's just do the code right now. So what is X? X is the input columns. And when I look at my machine learning model, the idea is this. You need to be clear about what you're predicting when you're building a machine learning model. We're going to use, now it's not the instant because we got rid of that. And we can certainly check it, right? I didn't actually check it. So perhaps it's worth checking. You can use as many df.heads as necessary, as helpful. And you can see it's not there. So the idea is I want to use all of these columns, the seasons, the months, the weathers, the temperature, etc., to predict the count, the number of rentals. Okay? So my Y column, when I'm trying to predict, maybe that's the easiest one, is the last one. And one way you can get the last one is df.iloc index location, all rows, comma, last column. It's always rows, comma, columns. Now for X, I want everything else. So I take all rows, and now I've got to start at the 0th column and go all the way up to, but excluding the last column. And if you're not sure that that's right, just check it. Do x.head, is it what you're expecting? Go to the end. Yeah, there's no count on this one. Okay. Now I fit it to x comma y, and we'll just score it on the same one. I just want to do put a quick one up. Why am I scoring it on the same one? Because we haven't split the data yet, which we'll do soon. But it's just a quick test, kind of a preliminary model, to see if one, the model works, and two, if the score is what we expect. When you're doing linear regression, the scores are usually only so strong because you were trying to force it into a linear relationship, and models often, or I should say data often not the optimal way to build a model. Okay, let's see what we get. We get 1.0. There is an issue here. Speaking of issues, like Chrome changed some things, and this is not connected, but I'm not trying to show the bookmarks bar. I think it's doing it by default. Okay, so listen to me carefully. Anytime you get 1.0 score, it's a red flag, and you've probably done something wrong. It's not always the case, but I can tell you that it is here. So do you know what it is? Part of it had to do with that element of carelessness that I took rushing to get the model up. Okay. What's wrong with this? Let's look at all the columns. Season, legitimate. These are, okay, so date columns, all legitimate date columns. Weather, shore, temperature, humidity, wind speed. Remember what the casual and registered are? It's covered in the last lesson. These are the number of people who like registered bike rental users and casual bike rental users. They combine to give you the count. Okay, so look, if you're using weather and date to determine the number of, say cyclists, you shouldn't know already the number of registered and casual cyclists of that day. You would not. Of course you get 1.0. The model figured out, hey, the relationship is linear. 0 times every column, and then like one of the casual plus one of the registered gives you the exact result. Okay, so this is simply not right. In fact, I want to change it because one strategy would be to get rid of these two columns. And then the other is, which one do we want to predict of the three? I actually want to predict the casual because I imagine that would be a little different. Like the registered, I'm assuming that the registered in advance, and the casual might be interesting to predict, and I've never done it. Any of those three are legitimate to predict. I've done the count, the CNT before. Let's just do casual. So how do I change that? I'm going to go back and change the code. Casual is the 1, 2, 3rd from the last. So instead of -1, it would be -3. And then we would take all going up until -3. So now if I rerun this, I'm going to get, we're checking it. See, there are no counts. And then the last one, the Y, should be the casual. And if you want to verify that, you can just put in Y. You could try y.head. It looks a little different, but this is the casual. It's named casual. It's because it's the series, which is Panda's way of only looking at one column. A lot of kind of things under the hood in Panda are designed to be fast. Okay, I'll tell you that. Okay, so now I can run this again, and I'm not expecting 1.0. I will actually be flummoxed if I do get 1.0. And we get what's more expected, like a score that you want to see when doing a preliminary sketch. Okay, so we caught one final piece, and I mentioned it before, I'll mention it again. You must be very careful when you're selecting the columns that you're using to predict your output. You've really just got to analyze it and look and make sure that the inputs are what you expect. And in this case, look, it's going to be a given day, so you'll know the season, year, month, holiday, weekday, working day. And the idea is that you will, if you have the information in addition to the weather, which these all are, that you can try to use those to predict the number of rentals. And furthermore, I will tell you that this initial score, it's based on the R squared, statistical score. And you can look at it as something like about 69% of the data is covered by the model. That's one way to look at it. Frankly, we're going to use the root mean squared error and get more into that coming up next, when now we build a machine learning model, you could say, properly.